Greetings. Hello, 9E and F. Sorry I'm late. I was looking up some stuff on, believe it or not, periodic table work for my 8th graders, and then I got distracted. So I have everything ready for you. Yes, hi. I'm writing you down right away. I got Jason, Leah, and Benedict. Super. Today's the 20th. Jason, Benedict, Leah. Let's see who else I got. Holy smokes, I got a bunch more. I got Lucy, hello, Tony, and Vincent. Lucy, Tony, and Vincent. Oh, they're going quick. I got Felina, Julian L, and Kira. I got Felina, Julian L, and Kira. Whoa, there's a lot of you. I've got Philip. I've got Shilpa and Santiago. So, Philip, Santiago, Shilpa. Good. I've got, this must be Natalie. 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 I've got Natalie. I've got Ben, Muriel, and Magdalena. Whoa, you're coming at me fast. I got Lee, Larissa, and Marla. Good. I've got Lena. Yes. And I've got Priya. I've got Sarah, Malek, and Dominic. I've got Noah. So far, I do not have, let me know if you're here. I'm missing Nicholas Heidrich. I'm missing Devante. I'm missing Julian K. I'm missing Aiden K. Deacon, Riley, Tom, Cosima, Christian, and Ali. From 9F, I'm missing Amir, Maurice, Noah Delphs, Lucy, Micah, Emily, Alyssa, who might be here. I know she has problems responding. Malin, and that is it. So if any of you are here, Malin is here. Good. Thank you, Malin. We'll start up in just a second. Let me put these off to the side and be ready to add some more people that are here and note you down. So it was nice to see 9E. I hope someday I will see 9F as well. That's my goal. 9F, I have talked to Frau Hinrichsen, and she said, we'll try and get you in at least before the end of the year one time so I can see you, get us together at school. I hope so. So you're not at the same spot. 9E, I'm going to take just a minute and review some stuff with you. 9F, this will be new for you, but then we're going to do stuff together. And I've got Ali here. Thank you for telling me, Ali. Good. Others, just when you join in, let me know. So here we go. we're starting a new unit, as 9E knows. It's called radioactivity. Or we're going to call it also as a group nuclear physics. Exactly. And Amir is here. Thank you, Amir. Exactly, Santiago. So we're going to be done really with eye problems, and now we're going to go on. Noah Delps is here. Hey, welcome, Noah. Nice to have you join me. Okay, so this is called nuclear physics. Okay. Everybody, you need a periodic table. So there's one at the back of your planner. There's probably one in your physics book somewhere if you want to look around for it. It would be really nice for you to have one both this time and next time. There's Emily. Hello, my Emily. Good. Right. Okay, why? Here's what's going on. Nuclear physics, so 9E will know this. Radiation means what's happening with a nucleus. What does radiation mean? 9E. Good, thank you, Marla. And Riley's, she can't see the video. It says I have an error command. Oh, Riley, I hope you can get it fixed. I think everybody else can see the video, so I don't know. Look around on your computer a bit and see if somebody there can maybe help you out. Okay, radiation. Good. Yes, good. And Shilpa has it and others as well. Yes, exactly, Riley. Okay, so something shoots out from the nucleus. And I'm going to add here, and 9E, you can add this if you want. Hey, Julian K is here. Thanks, Julian. Dynamite. Okay. So 9E, you can add this to your notes if you want to. Here we go. Something shoots out from the nucleus of an unstable atom. So literally, everybody, if this is my atom, okay, and I don't care about the electrons, we only care in nuclear chemistry about the nucleus, to be really honest. So even though we spend so much time on electrons, now they don't matter that much, unless they have to do with, anyway, we'll come back to that. So here's my nucleus, protons and neutrons in there, right? Okay, but something's going to happen. It's not stable the way it is. Something comes off. The something could be a particle or it could be a type of light. And that's what we're going to look at today, everybody, because all this will be new to all of you. We're going to look at the 3 types of radiation today, okay? So just in general, here's my nucleus, and something comes radiating up. Okay, that's radiation. Radiation can be a bad thing, it can harm your cells, or a good thing. It can be used to kill pests in fruit. It can be used to kill cancers. It can also cause cancer. So thank you very much, Leah. That's what I thought. Alyssa, you're all set. Thank you, Alyssa, for being there. That sounds fine, Riley. Good. Ionizing radiation. Yes, sometimes radiation can ionize stuff. Oh, so many good comments. Right. Yes. Alpha, beta, and gamma, the 3 types. Santiago has one already. Good. So let's kind of consider what's going on. So I'll just say radiation can be bad. Well, yes, it can harm cells. I'll just say can harm us, okay? Can harm our cells in our body. Good. It has uses that kill tumors, so destroy tumors in the body if someone has a cancer or a tumor. So used in cancer treatment and elsewhere. So, and that should be new to everybody, including 9E as well. Infrared, Emily, is a type of light, but it's not really a type of radiation. But I'm glad you're thinking about it. So we're going to check out the 3 types in just a second. I think that's all I want you to know for now. So radiation, you've heard of it, nuclear radiation. It sounds scary, right? Sometimes we hear of it in nuclear power plants, or if there's a nuclear bomb, as of during World War II. It's a scary thing. It can harm us, definitely. But it has some good uses too. And once we understand the types of radiation, we're going to talk about some applications, good, bad, whatever, and where it's found in our society. Maurice is here. Thank you for joining us, Maurice. Okay, so without further ado, we're going to jump into it. Ready? Here we go. 3 types of radiation. I'm going to change boards, okay? You all set with that one for the most part? There's not too much on it. Hopefully you got it. And I'm going to take it away. Whoop. Okay. Let's get whiteboard number 2 up there. Okay, you ready? You're ready. Okay, so here we go. 3 types of radiation. To talk about this, we're going to make a chart, a really big chart. So let me get all the columns, and then you can see how it's going to look in your notes, right? Ready? Here we go. So we're going to say the name, the symbol, the name, the symbol, what is it? What is it? How penetrative? How penetrative means how can we block it? How much does it go through you or whatever? And I've got some little pieces of metal and stuff to show you under all my goodies here. Gosh, I got so much stuff here. Where is it? It's down there somewhere. I'll get them out. Anyway, I got some stuff to show you to think about how to block it. Okay. Okay, how penetrating? Yeah, and we'll just say blocked by. No, no. The fancy word is shielded, like a shield, right? From a old-fashioned knight or something. Okay, so you ready? Here we go. Okay, so, or however you want to do it. Okay. Oh man, that's like the worst column ever in the history of the universe. My column writing things are not great. Okay, let's hope my physics is a little better. All right, sorry about that. But you got it. So we got name, symbol, what is it? How penetrative is it? And shielded by. Okay, so they are alpha. They're all Greek letters, okay? Beta. And a few of you knew this one already, gamma. Those are the big three, okay? Those are the three I want you to know. There's other stuff that can happen in the nucleus, but frankly, you'll get that in a Grundkurs or Leistungskurs. This is the big three, alpha, beta, gamma, okay? Here are the symbols. I'll try and make them big. Let's make the symbols in blue, okay? So alpha looks like a sideways fish. Here we go. That's alpha, okay? Beta looks like the German letter Etz, okay? And gamma looks like a fish too that's swimming down. Okay, maybe a little skinnier fish, but swimming down. Kidoki? Yeah, and you're right about beta, Santiago. We're going to get there in a little bit. Okay, let's go to what's going on here. What is it? Okay, for alpha, some nuclei, remember when I say nuclei, now we're talking about just the middle of the atom, right? With the protons and neutrons. Remember that from 8th grade, I hope. So here's a nuclei. Some of them are just too big and they're not built the way they are to be stable, especially some big atoms, bigger than uranium even. Although some types of uranium are radioactive too. So what happens is a piece comes off and literally there's less of it left, okay? So the alpha piece, when it comes off, it looks like this. And you might say, Mr. Weiss, I can't even tell what you're writing. Okay, here's what that is. The piece that comes off for alpha is a little tiny helium nucleus. So I'll write helium, He, you know what that is, nucleus. And it's got a helium nucleus. Man, where am I going to write this? It's got 2 neutrons and 2 protons. So I better write this down below, okay? I kind of ran out of room. So I'll put a little star here, okay? So this little piece, that little star up there, ready? That's representing a little tiny particle made of 2 protons and 2 neutrons. And it just flies out of the nucleus, okay? Shwam, blah, there it goes. Okay, while I'm going nuts here, I got to get my other little doohickeys. There they are. All right, hallelujah. Let's do beta. Let's do beta. Oh, no, let's not. Let's finish alpha. Okay, so how penetrative is it? Okay, because it's so big, right? Here's my nucleus. Here's my alpha particle coming off. Because it's so big, it's fairly easy to block. Even a sheet of paper can shield you from that. Okay, so beta has a very low penetration, shielded by even sheets of paper. Or, importantly, your skin shields you from this as well. Okay, I see 1 or 2 other people have joined us. I sure will. Okay, so I'll do that for you, Leah, in just a moment. Let me just make sure I got everybody here. Do I have Lucy? Is she out there? Lucy, I got, but do I have Lucy? Do I have Micah? 9F, everybody else is there. Awesome. 9E is missing some folks. Do I have Christian, Cosima, Tom, Deacon? Do I have Aiden K? Do I have Nicholas? Any of those folks? That's fine, Lee. That's okay. All right. Okay, so Leah asked if I can hold this thing closer. So let's just bring the laptop closer. Ready? Okay, Leah. How's that working? Ooh, not so well. Let me get my camera there. Okay, is that a little bit better? You can see what the heck's going on? I hope so. Hey, Tom is here. Okay, good. Tom, I'll write you down in just a second. All right, hopefully Leah and others, you got that down. I'll review a little bit in a second. Let me write down Tom. Okay, so I got alpha, beta, gamma. We're doing alpha right now. It's a helium nucleus, 2 protons and 2 neutrons. It doesn't have a lot of penetration because it's so big, and it's fairly easy to stop. I can use paper or even my own skin can stop alpha. All right, Ute. Let's go on to beta. All right, so beta, what is it? Santiago said it earlier. Does anybody else know what beta is? What is beta? Maybe you had another class or another school or something. Well, beta is, Tom knows it too. Good. It's an electron. So I'll just write E minus. Beta's weird, so don't think beta's easy. Yeah, exactly. They get shot out of the nucleus, Tony, so they are fast when they come out. How penetrative is it? Medium. I can't stop it with a sheet of paper. It'll go through that. Exactly. It goes zooming out. So I could stop it with something like this, maybe some sheets of like aluminum. All right. So something on that order. Okay. One or more sheets of aluminum, and I could do this. Cosimo's here, just has a bad connection. Thanks, Lynn, for sharing that with me. Cosimo, thank you for joining us this morning. Ute. Let's do gamma. So what is gamma? Let's see if somebody just knows that from another school, another class, whatever. What is gamma? Highly energetic photons. You are right, Tom. And Tom, don't write it in, but somebody else. So what are photons? What is Tom talking about? What is photon? What does that mean? What's coming out? What's coming out of the nucleus? What's a photon? Somebody else. Santiago knows too. Let's see some other folks type in. What's coming out of this nucleus if gamma happens? Yeah, they're kind of a wave. Yep, you're getting warm, Jason. That's right. Gamma is a type of wave. Therefore, it's a type of, Magdalena has it. So does Tony. Light. So what is it? It's a type of light. So it's a light wave if you want to go in that direction that Jason went. So it's a light wave. How penetrative is it? Because it's a wave, it can go right through you. So its penetration is high. How penetrative? Highly penetrative. Okay. And what I got to show you how to block it, exactly, Priya, what I got is something I can't even show you at school, but I brought one home because we have some in the physics department. This is really heavy. And what element do you know is really not heavy? What's the word? Dense. What's really dense and what could that be? And we'll see where it's used. If I have you at school, I'll try and show you a big piece of this. Oh, a lot of you got it too. Yeah, starting with Shilpa and many others. Good. This stuff is lead. Feels like a ton of lead. Well, a ton of lead can be useful. Here's how you spell lead. It looks like lead, but it's spoken lead. So if I had a nuclear power plant, the lead would be like this thick. It's a way thicker around the chamber where the nuclear power is being created. And we'll diagram a nuclear power plant in the coming weeks, okay? Okay, let me tell you where we're going, by the way, all right? So we're going to talk about, in an equation, an example for each of these, what happens. We're going to talk about where it's used in nuclear bombs. Yep, I'm going to teach you how to make a nuclear bomb. Please don't do it at home. And we're going to talk about nuclear power plants and how they generate electricity. Okay, what parts are safe, what parts are maybe not so safe, why people worry about it. And we'll talk about nuclear disasters after that as well. Fukushima, Chernobyl, 3 Mile Island, and see what went wrong and how it can be prevented. Okay, that's the direction we're going. All right, let me look here. Alpha, beta, gamma. I'm going to write another little column here. For alpha, what shoots out of the nucleus? That shoots out. The little thing that shoots out is this little group, Leia, of 2 protons and 2 neutrons. So imagine I got this big nucleus like this. Out of this thing, Leia, comes 2 protons and 2 neutrons. So they go, whoa! Okay, and I still got most of the nucleus left. Okay. Any other questions before we go on? I may add one other column here. Kinetic energy. I think we had that term already. I hope so. We're going to ask you in a second. Okay, kinetic energy is really high for alpha. It's low for beta. And because gamma is a type of light, we're not going to talk about kinetic energy with it as such. We'll talk about other energy with gamma. So kinetic energy of the particle, basically. Kinetic energy, hey, Leia has it. Thank you, Leia, even before I asked it. She's right, it's energy of motion. So alpha has a lot of kinetic energy because alpha particles are relatively big, okay? Electrons are really small, so they have a low amount of kinetic energy because they're very lightweight. So they just don't have a lot of oomph, okay? And gamma is a type of light. We'll come back to gamma. Good, so add that last little column if you can squeeze it in on your paper. And Jason has a good question. How do they check how much radiation there is? Right, so my 9E group knows it's using a Geiger counter. And Jason, the German is Geiger-Müller Zähler. So if you've heard of either one of those, they hold it like this. You might have seen it in the movies, and it goes like this. Click, 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 right? And the more clicks, the more radiation. My 9E group got to see that, and I hope 9F I can show you one too at some point. I'm going to tip this a little and just hope that you can see most of that if I do so. And we're going to change boards. I'm going to erase. While I'm erasing, you guys think if you got another question. You're welcome, Jason. All right, so I'd love to do it here, but we ran out of room. So we're going to do a reaction, a nuclear reaction, so to speak, for each of the 3 types, alpha, beta, gamma, right? Okay, we good? All right, I'm going to put this down. If you got a question, I'll pull it back up before I erase it, but let's change for now. We still got some time? We still got some time. We could do this. Okay, so here we're going to go radiation type, and we're going to go sample reaction. And in nucleus, what happens? Okay. Leave a bunch of room here, okay? So this doesn't take much at all. We need a bunch of room here. And then I'm going to write here, in nucleus, what happens? Okay, you ready? It's going to be the same as before, alpha, beta, gamma. Let's do alpha first, okay? So I'm going to do the alpha symbol, right? So draw yourself a little fish. And I'm going to just make something up. I've done this a lot, so I could just sort of look on the periodic table and say, oh man, let's see, plutonium 94. I know that's pretty radioactive. I'm going to imagine an isotope. Ooh, gosh, if we had that, I hope we did. We're going to find out real quick. We'll find out real quick. All right, so here we go. Let's take as an example plutonium, Pu, not because it smells, but just because that's its symbol. So plutonium, Pu, it's got 94 protons. And the number of protons goes down below. You ready? So we're going to put 94 in that lower left corner. You might have done this before. If not, you're going to learn something new. Okay. And let's say it's got a number up here, and I'll tell you what this is in a second, which is bigger. Let's see, it's got about 246. All right, you might say, Mr. Weiss, what the heck is all this? All right, here we go. I'll write it over at the side here. We got some room here, okay? The 94 is the number of protons. That's always goes in the lower left corner. It's called the atomic number. So that sucker, atomic number, it's the number of protons. Okay? You can make yours neater than mine, but I only got so much room on the whiteboard. Okay, so don't isotopes just have the same number of protons but different number of neutrons? Yeah, but like I can say it the other way too. Kira, anything is an isotope. In other words, I can have one isotope and then another with a different number of neutrons, and then another with so I could have 3, 4, 5 different isotopes. But this is also an isotope. Isotope just means whatever special number of protons and neutrons you got. Okay, so she's done this with me. Let me make sure everybody else knows. The top number, yeah, I'm going to use a little more room over here, is called the mass number. That's the mass number. The other one was the atomic number. Folks who've had me before, or if you know it from another group. Kira knows, so Kira, somebody is, the atomic number, this top 246, that's the number of what? The bottom's the number of protons. What's the top number, top upper left? See that, everybody? And I put 246. That's the number of what? It's called the mass number. And it's where most of the weight comes from for the atom. So it's the number of and What's the mass number? You can Google it madly while you're talking to me. Hey, Sarah knows. So does Magdalena. Good. Okay, so here we go. So the mass number is the number of protons plus the number of neutrons. Oh, okay. Good. A lot of you got it now. Thanks for participating. Appreciate it. So let's see what happens. Okay, remember what alpha was. Alpha's a helium nucleus. You got that? So what's going to form? So there's my stuff. Plutonium-246 is the isotope. It's going to shoot off a helium nucleus. So I'm going to write helium. And helium has 2 protons. And if it's a nucleus, it's got 2 neutrons as well, so the top number is 4. And it's a helium nucleus, so it's got no electrons, so it's 2 plus. That's a big old complicated symbol, isn't it? Plus you can't see it because it's in the smear. So here we go. So it's helium 4 2 plus, or you ready for this? Or you can just write the symbol alpha. So sometimes you'll just see scientists write this instead of that whole helium nucleus. Okay, then plus, because I don't want to run out of time here. Plus, what's left? Well, you got to do a little subtraction. Here's what I mean. I got 246 and 94. Well, I got 94, but 2 of the protons left. I got 246 protons and neutrons, but 4 left. The 2 plus doesn't matter at all. We don't care about the 2 plus. We only care about what's going on in the nucleus. So I need you to help me out with some numbers here. So what's left for my bottom left number? What's left for the new mass number? It's not 94 anymore. What's it going to be after the alpha radiation, after the alpha decay, it's called? That's another word for radiation, decay. Okay, so what's my bottom number now? It ain't 94 anymore. Lee knows, so does Santiago and Sarah. It's 92, that's correct. And it's simply subtraction. 94, take away 2, because 2 protons left, you got 92 left. Good, let's do the top number. 246, well, what left? 4 left, so I got what left at the top for my new mass number? 200 and? It's your morning subtraction here, or afternoon. Now we got it. Leia's got it. Sarah's got it. So it's 242. Well, what is that, gang? Well, let's look on the chart. 92 is what element? So find element number 92 for me. What has it become? It's changed identities. It's no longer plutonium. It's now 92. Who is that? Remember, the bottom one tells who it is, right? The number of protons, the atomic number. Good. Sublove, you've looked it up, including Shilpa and Tom and others. It is uranium, so U, big capital U. Whew. What happens in the nucleus? What happens? The nucleus, as you could probably tell now, although it's kind of in the smeary light there, the nucleus is getting smaller. So nucleus, I'll just write, gets smaller. And maybe it's getting more stable. The 9E group, we talked about whether things are stable or not. So this plutonium must have been unstable, and the uranium is probably more stable. Now, everybody, that may not be the end product. This may go on and become, it may be not real stable itself and may go and do another decay and become something else. So we don't know if this is the end of the story. How do you know? You got to do a lot of scientific work on it. And many, many men and women have done this over the years, okay? So they know from a lot of people's work what's stable and what's not. But we're just going to deal with one step at a time. First step, unstable plutonium becomes this isotope of uranium. The nucleus got smaller. Yeah? Okay. Questions so far? All right, let's at least start with beta. Beta, we're going to go over here first, because for beta, something weird happens, okay? Beta is strange, okay? Here's what happens in a nutshell. a neutron in the nucleus becomes a proton plus an electron. And it's not done yet. The electron then shoots out of the nucleus. And you might say, well, how can it do that? That is so weird. Well, think of a proton as being made of an electron and a neutron. And that's essentially actually what they are. So, and now I like to do the analogy, we got another minute. I like to do the analogy Superman. You ever see those old movies of Superman? He goes into a phone booth, spins around, and becomes Superman. Well, think of this. A neutron goes into the phone booth, spins around, and becomes a proton. So neutron spins, becomes a proton. To do that, the electron's got to fly off. Okay? It sounds like magic, but it's really not. Think of it. There's my proton. Really, it consists of a neutron and an electron. So I can go, hocus pocus. There goes the electron. Okay, I got left a neutron. No, sorry, I said that wrong. Try it again. Pressure. I know, time's run out. Let's just do this real quick. Here's my neutron. So, boom, there goes the electron. A proton is left. So we've gained essentially a proton, okay? In numbers, we gain a proton. We'll pick it up from there next time, gang. Thanks, everybody, for participating. We're in an okay spot. We'll start again with beta next time I do a live stream with you. So thanks, everybody. Have a good vacation day tomorrow.